Hey everybody, today's lesson is going to cover converting fractions. Now there's going to be two things that can happen when you convert fractions. They can either terminate, which means you get a remainder of 0, or they'll repeat, where you get the same number over and over and over again. Now one thing I always like to start on when I am covering fractions is that inevitably people are going to want to use their calculators, which is understandable. Now you're going to be expected as 7th graders to know how to do this without a calculator. Just as a little bit of heads up here, you want to kind of be on the lookout for this because I'll always have students that when you convert a fraction to a decimal on a calculator, it's pretty simple math. It's a matter of just pushing a few buttons. You just have to do top divided by bottom. You just have to do 7 divided by 9, numerator divided by denominator. Then what will happen is you'll see your calculator screen and you'll notice that it seems like it's repeating. There's all these repeating digits right here and right here. And then all of a sudden, there's a number that is different. And students will always come up to me and say, well, Mr. Oliver, you know what? I don't think that number repeats because there's an 8 on my screen. There's a bunch of 7s, but the very last number on my screen is an 8. And the reason for that is simple. The point of this part of the lesson here is to show you that your calculators, depending on what the last number on the screen is, depending on that number, your calculator is going to round the very last digit on the screen. It's going to round that last digit. So the last digit really is a 7, and there's no end to the number of 7s. The 7s keep going and going and going and going. There's basically a 7 right here, but your calculator is just programmed to round that very last digit on the screen. So just be on the lookout for that. And then sometimes people will say, well, how come I did, let's say they did, 4 divided by 9. And then if you try that on your calculator, you're going to get 0.4444444444. And for some reason, there's no 5 at the end. And the reason for that is because of a rounding rule. Because what's the next number after the 4? Well, another 4. And the rule for rounding is that it has to be 5 or more to round up, right? 5 or more raises the score. 4 or less, let it rest. So the reason that you don't see a 5 on your calculator screen sometimes, or another number that goes up, is because the numbers aren't bigger than 5. They're not 5 or bigger, I should say, 5 or greater. Now, diving right into our first example here of converting fractions into decimals, you as 7th graders are expected to be able to do this without a calculator. When you do this using just your pencil and paper arithmetic, you're going to want to do top. So the top number is 5 divided by 8. And that looks really yucky. I know as a math student, you're looking at that and going, oh, that does not look right. First of all, why is this number big? And you're used to when you're dividing, of course, you're dividing by a smaller number. But that's not always how math is. So what we have to kind of do is, well, let's make this look a little less yucky, I guess. And you can always put a decimal right there. There is a decimal there by default. And then you can add any number of zeros that you want to add. You can add as many, because adding the decimal point and making that 5.0 or 5.00 or 000, it doesn't change the fact that it's still 5. This number right here inside the dividend is still the number 5. Let's say one of the bigger mistakes people make is they start adding zeros here, and then you'll notice that, okay, we added zeros, but what happened to the dividend? The dividend's now changed. Now we're doing, depends on how you're looking at it, but this right here, this is 50,000 divided by 8, and that's not what this is. This is 5 divided by 8. So putting that decimal right there is very, very important, and then also bringing it straight up into the quotient is a huge deal as well. So again, you can add as many zeros as you want. Granted, you put a decimal point right there. That's very important. You put that decimal point in that spot. Otherwise, you're making it an entirely different number. Okay, so let's start with our arithmetic here. And again, we're going to start with we're going to do our dad, mom, sister, brother, rover algorithm, which is just a way of remembering the order in which you divide. So you divide. After you divide, you multiply. After you're done multiplying, you subtract the number you got, and then you bring down the next number in the dividend, and then you repeat. Now, R also stands for remainder. But with decimals, we never ever leave remainders. So repeat the process, which means go back up to the first step. So that's your division algorithm, the dad, mom, sister, brother, rover. You might have learned that in elementary school or had an elementary school teacher like me who taught you that way, and I've always remembered it that way. Okay, so we're going to divide. So how many times does 8 divide into 5? Well, it doesn't, so I'm going to put a 0 right there. How many times does 8 divide into 50? 8 times 5 is 40. Maybe I should use 5, but let's see. 8 times 6 is 48. 8 times 7 is 56. So I don't want to be bigger than 50. I want to be less than or equal to. So we're going to use 48 there. So I'm going to put a 6 there in the quotient. All right, so we just divided. And then we're going to start the algorithm here, which is going to be multiply. So 6 times 8 is 48. Subtract, and you get 2. 50 minus 48. And then you bring down a 0. All right, so now we're ready to repeat the whole process over again and start dividing. So again, we're going to divide 8 into 20. How many 8s divide into 20? That should be the question you're asking yourself at this point. 8 divides into 20 2 times. 2 times 8 when we multiply is 16. Subtract. So when you subtract, 20 minus 16 is 4. And then we're going to bring down a 0. Now you see, annexing those zeros, see those zeros that we added here, really do help with the division. If we didn't have anything there, if we didn't have anything there, 8 divides into 5, it would be confusing as to what do we bring down. But knowing that you can put a decimal here and putting zeros there tells you that you can bring down as many zeros as you please until you figure out whether it terminates or if it repeats. Now we're going to do some more division, and this time we're going to divide 8. We're going to look at how many times 8 divides into 40. Now 8 divides into 40 perfectly. It divides into it 5 times. And then 5 times 8 is 40. Subtract, and we get 0. So when you get 0 as a remainder, and again, we don't really like remainders with decimals anyway, but when you get 0, this terminated. So there is your solution. So our solution is 625 thousandths, or 0.625, if you don't want to be all fancy with the way you're saying your decimals. So 0.625. Okay, so let's start this one out. Let's do top divided by the bottom. And again, this looks really weird. Like, why would we divide 20 into 7? And that makes sense. But if we add a decimal point, and if we add as many zeros as we feel that we need, and the question sometimes I get is, how many zeros do I need to add? And that's kind of up to you, because as you're doing the arithmetic, as you're working it out, you'll find that you'll need to add just a couple zeros. Sometimes you just add 1 0. Sometimes you don't need to add any. But what you want to do is you want to start noticing a pattern. And whether there's a pattern or if it terminates, you'll be able to tell whether it repeats or if it terminates. Now that decimal point comes straight up into the quotient, so make sure you bring in that straight up. And let's start dividing. So let's follow the dad, mom, sister, brother, rover algorithm. And then 20 does not divide into 7, so we're going to put a 0 up there in the quotient. And then we're going to divide 20 into 70 first. 20 into 70. How many 20s divide into 70? Well, 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. 20 times 5 is 100. I know I passed it, but just wanted to show you some 20s there. But yeah, we're going to probably want to use 20 times 3. So we're going to use a 3 in our quotient, and then we're going to multiply. We just divided, we got a 3, now we're going to multiply. So 3 times 20 is 60. Now the next step is subtract. So 70 minus 60 is 10. B stands for bring down. So we're going to bring down a 0, and now you have 100. And then we're going to repeat that whole process over again. So we're going to divide. How many 20s divide into 100? Well, that just happens to work out perfectly. 20 times 5 just happens to be 100. So another example here of a terminating decimal. because we got 0 as a remainder there. So our solution is up here, 0.035, or 35 hundredths, if you want to be all fancy with your mathematical language and terminology. 35 hundredths. And you might have also noticed that we didn't end up using these zeros at all. You might think like, oh, did I do something wrong because I didn't bring those zeros down? No, they just weren't needed. We just didn't end up using them. So if you end up having extra zeros in your dividend that you never brought down, that's okay. You don't want to leave any non-zero numbers up in the dividend that you didn't bring down. But yeah, those zeros right there were just extra superfluous zeros that we didn't really need. And sometimes you do. Sometimes you need a ton of zeros. But this time around, we only needed 1. Okay, now this is a mixed number. So what happens with mixed numbers, what I would recommend doing with mixed numbers is changing it into improper first. So let's change it to improper. So multiply 25 times 6. 25 times 6 is 150. And then 150 plus 3 is 153. So you got 153 on top. And then 25 was your denominator before, and it's your denominator again. So you got 153 over 25. So there's your division problem right there. So we're going to do top 153 divided by 25, divided by the bottom. Top divided by the bottom. And again, I think if we're following a general rule here, I'm going to add a decimal point, and we're going to add as many zeros as we think we need. And then bring that decimal always, bring that decimal straight up into that quotient. That's very important. Okay, so now let's follow that dad, mom, sister, brother, rover algorithm. Divide, multiply, subtract, bring down, repeat. Divide, multiply, subtract, bring down, repeat. You want to get that in your head. You want to be able to do that automatically. You're like on autopilot. Okay, so 25 does not go into 1. 25 does not go into 15, but it does go into 153. So it goes into it 6 times. We're going to put a 6 in the quotient. Now we're going to multiply because we just divided. So 6 times 25 is 150. All right, we multiplied. Now we're going to subtract. Now, this is not really difficult subtraction here. We're just going to subtract and get the 3. Bring down a 0 here. And then repeat. We're going to repeat that whole process over again. So how many 25s divide into 30? Well, this is pretty simple again. Only once. So you're going to do 25 times 1, which is 25. Subtract, you get 5, and then we're going to bring down another number. So we're going to bring down a 0, all right? And then repeat. So how many 25s divide into 50? Well, that works out perfectly again. 2 times 25 is 50, exactly. So what is that called? That's a terminating decimal. So we got 6.12, or 6 and 12 hundredths. All right, and the next example, we have another example of a mixed number, and it would do you well to change that into an improper fraction before you go any further. So multiply 15 times 3, which is 45, and then add the 8 on top of that. So 45 plus 8 is going to be 53. So you got 53, and then 15 was your denominator before, and it's your denominator again. Remember, your denominators stay the same when you convert it into a mixed number. So you got 53 over 15. So that's what we're going to do for our arithmetic here. We're going to do top 53, and I'm just going to go ahead and change that to a decimal right now. So 53.000. Add as many zeros as you think you're going to need, because we're never sure how many we're going to need. And then we're going to divide that by the bottom, which is 15. So top divided by the bottom. 53 divided by 15. Now the decimal goes straight up into that quotient, and now we're ready to divide. How many 15s divide into 53? Well, that's going to be 3. So now we can multiply. 3 times 15 is 45. Subtract, and you get 8. All right, and then we're going to bring down the next number in the dividend, which is a 0, which is what we added. But instead of putting 3 remainder 8, which is not how we do decimal problems ever, we're going to put a 0 down into that number, and we're going to keep dividing. So how many 15s divide into 80? Well, how many 15s divide into 80? Here on the side here, I'm just going to do some 15s. So 15 times 1 is 15. 15 times 2 is 30. 15 times 3, 15 times 4 is 60. 15 times 5 is 75. 15 times 6 is 90. 15 times 7 is 105, and I'll stop there because I know you see it already. So we're going to go ahead and put that up in the quotient. So 15 times 5, or we're going to do 15 times 6? Well, it's 5 because we don't want to be greater than 80. So we're going to put a 5 up in the quotient, and then we're going to multiply. So 15 times 5 is 75. And then we're going to subtract. So 80 minus 75 is 5. Okay, but we're not going to put 3.5 remainder 5. We're going to keep plodding along here. Bring down that 0. Now it's 50. So now we're going to divide we're going to look at how many 15s divide into 50. Well, 15 times 2 is 30, 15 times 3 is 45, and 15 times 4 is 60. So times 4 would be too big. Times 3 is smaller, so we're going to use the 3. So 3 times 15 is 45. Subtract, and you get 5, and then we're going to bring down the 0. And we got 50 again. Now maybe light bulbs going off in your head at this point. You're like, wow, I got 50 again. That's interesting. So let's do that again. I got 50. Am I doing something wrong? Let's try this again. So how many 15s divide into 50? Well, we just did that. So 15 divides into 50 3 times. And then when we multiply 3 times 15, we're going to get 45. Well, that looks familiar because we got 45 before. And then when we subtract, we're going to get 5. And that definitely looks familiar because we got 5 before. And we're going to bring down another 0. So we've got 50. And you're going to notice at this point right here, this is a never-ending repetition of 3's. No matter how many times we do it, we're always going to get 50. We're always going to multiply and get 45. We're always going to subtract and get 5. And we're always going to bring down a 0 and make 50 again. So it's always going to be this repetition, this repeating pattern of 3's. 3, 3, 3, 3, 3, 3, 3. So the way we deal with that, the way we handle that is with this thing called bar notation. Now, bar notation basically just means put a bar above the number that's repeating only the repeating digit. So we're going to write 3.53, and then we're going to put a bar above the 3. The digit that's repeating is the 3. If I put a bar above the 5, well, I'm saying it's 3.5353535353. And that's not what it says. It's only the 3 that's repeating. It's 3.53333 forever. Forever and ever and ever. And that is your answer. That's our first problem right there where we ended up getting a repeating decimal. So 3.53. All right, now let's do one more for good luck right here. Let's convert 18 7/8 into improper fraction. So 8 times 18 is 144. So 144, and then 144 plus 7 is going to be 151. 8 was the denominator before, and it's our denominator again. So this time we're going to do 151 divided by 8. And just like we have been doing, let's put a decimal point here and add a couple zeros if we want. Add as many zeros as you want, but bring that decimal straight up. Now let's start our math here. So how many 8s divide into 1? Well, 8 does not divide into 1. 8 does divide into 15 though. So 8 divides into 15 only once, almost twice, but once will work. So we're going to put 1 times 8, which is 8, and you're going to subtract, and you're going to get 7. Now there's a 1 right there. So we're going to bring that 1 straight down, and then we're going to divide 8 into 71. How many 8s divide into 71? Well, that's going to be 8, because 8 times 8 is 64. 8 times 9 would be 72, which would be too big, just a little bit too big. So 71 minus 64. We're ready to do the arithmetic here, which is 7. At this point, you're like, oh, I wonder if this is repeating. I got a 7. But, well, this time we got 70. So, even though we're getting similar numbers, they're not exactly the same. We got 71 before, and this time we got 70. So I don't see anything repeating yet. So don't automatically assume it's repeating. So now we're going to divide 8 into 70. How many 8s divide into 70? Well, that is going to be 8 times 8. 8 times 8 is 64. Subtract. 70 minus 64 is 6. And I haven't seen anything repeating yet. So we're going to put a 0 down here. Now we're going to divide 8 into 60. We have not done that yet. We have not divided 8 into 60. So how many 8s divide into 60? Well, 8 times 8 is 64, so that's too big. So it's got to be 8 times 7. 8 times 7 is 56. And when you subtract, you get 4. And I ran out of zeros. Well, that's the only reason I ran out of zeros is because I didn't draw enough zeros here. So remember, you can put as many zeros in the quotient as you want, as long as you put a decimal right there. So now I'm going to bring down one more 0, and this should do it. So how many 8s divide into 40? Well, that's 5 exactly, because 5 times 8 is 40. And you get 0. So did this quotient, did that terminate or did it repeat? This one definitely terminated. Okay, that does it for this lesson, everybody. Hopefully you guys understood how this goes. I think with dividing I understand is not the easiest thing to do. It takes a lot of persistence and you got to keep going. Sometimes if you don't see something repeating, keep going. You know, sometimes it takes 2, 3, 4, several more steps before you notice a number that's repeating. And it just takes a lot of persistence when you're dividing, especially when you're looking for repeating decimals. Same thing for terminating decimals. If you don't notice any pattern and it's not terminating, maybe there's a little mistake with your arithmetic somewhere along the line. So go back and recheck some of the work you did and see if you made a mistake somewhere. Maybe you put the wrong number down. And that happens to me. I'm a math teacher. I'll bring the wrong number down. I'll write the wrong number down by mistake. Those things happen. We're human beings. So look back at your math and see what happened. Okay, so that does it, everybody. Have a great day. See you later.